Hello everyone, welcome to the Innovation Lab. In this video, we're going to be conducting a full review and comprehensive test of this 38 volt 55 amp hour lithium phosphate battery pack that is made by LiTime. And in this video, we're going to be pushing this battery to the limit to make sure that it actually meets all the energy storage specifications that the manufacturer had listed for this product. The main focus of this video is to really take our time to go over all the specs of this battery system. Alright guys, in this video the plan is to first of all conduct an initial charging test on the battery system, and we're going to use our DIY battery charger to accomplish that, and followed by that will be an initial steady state discharge test, and the overall plan for that is to use the battery system to drive a reasonable load so we can see how long the battery system will last while driving that load. Also, we're going to conduct a solar charge test. Again, we're going to use our DIY solar battery charger, and the goal is to show you guys if it is going to be possible to use our DIY solar battery charger and an array of solar panels that we have to be able to recharge this battery fully and how long that will take. And lastly, if time permits, we're also going to be able to conduct more tests on the battery system, like a trolley motor drive test, and this will help us to show you guys more and more of what you can possibly do with a battery system like this. Everything we're going to be sharing with you guys in this video is going to be our honest and tested opinion about this battery system. The plan is to shuffle things around a little bit to keep the video fun and interesting, and we usually add chapters to our videos to allow you guys to skip around a little bit to get to the sections that you find more interesting. Alright guys, let's jump right into it. Alright guys, as you guys know, we're big on safety. Whenever you're working with electrical energy, whenever you're working on any kind of power system or electronics, you have to make sure that you're being safe. You have to maintain a very good or high level of cleanliness and orderliness. And on our test setup, as you guys can see, we actually have a way to look at every single parameter that we are measuring, from input voltage to output voltage to charging currents to a cooling system that we actually have to cool our DC to DC boost converter that we're going to be using for both charging and also discharging the battery during the discharge cycle. So essentially, the oscilloscope that we have on our test setup here is what I'm going to be using to monitor or keep an eye on a few parameters depending on what test that we're conducting at the time. During the charge cycle, I'll be more interested in looking at the peak-to-peak and RMS ripple that our DC to DC boost converter is going to be sending to our battery, because this is a DIY charger that I've always used and it works well, but also I always like to keep an eye on things. I also like to look at the PWM control signals that is driving the DC to DC boost converter just to know what is going on. Also, on our test setup here, as you guys can see, we have a circuit breaker. This is a 60 amp circuit breaker. So if anything happens, or if by mistake we short the battery terminals, the circuit breaker will be there to protect us because it's gonna trip. So the very first thing that we did after we received the battery was to first of all inspect the packaging of the battery, and followed by that we conducted an initial voltage measurement. This battery was coming in at an initial voltage of 39.53 volts. So what I did was to take that initial voltage measurement of 39.53 volts and kind of try to use it to extrapolate the SOC percentage that the battery is coming in at. So the SOC percentage, SOC is the state of charge of the battery, kind of tells us how much charge capacity that the battery is coming in at. And with all of that in mind, we're going to see how all the numbers will line up between the initial charge that this battery came with and the amount of charge that we're going to put into the battery. Then we compare it to the actual rated capacity of the battery. So for the actual charging process, we're going to use our DIY charger, which is nothing but our server power supply and our constant current, constant voltage DC to DC boost converter. As you guys know, our YouTube channel is big on showing you guys affordable DIY methods, especially around battery chargers that will save you guys a lot of money. We can't be preaching something else and come to this and go buy a brand new charger to test this battery. So we're going to use our DIY charger. So the first thing we have to do is to adjust the output of our DC to DC boost converter down to about 43.8 volts. And after that, we close the circuit breaker to connect the battery to the charging system. Also, an additional layer of safety is that we always look at everything. So because this is a brand new battery, we don't want to be careless with it. So I connected my oscilloscope so we can look at the charging ripple voltage level, RMS and peak to peak, to make sure that our converter is actually not introducing high ripples to the battery system. So the next thing we really get to do is to now slowly increase the charging current. So we increase the charging current until we get to about 11 amps, which is the recommended charging current. So initially, with the battery connected and our charging current set at 11.08 amps, the initial charging voltage at 40.36. So we were pretty much delivering about 447.18 watts going to the battery. So we left the battery to charge for a while, and we came back after about 2.5 hours to see how things are going. And what we saw was a charging voltage of 40.75 volts and a charging current of 11.24 amps. So all of that gave us about 458.03 watts going to our battery. And to be safe, one of the things that I had to keep an eye on was the battery temperature as we're going through the initial charge process to make sure that everything is working fine. And we measured a maximum temperature of 29 degrees Celsius. So with the initial measurements and observations, I was able to verify that the battery system is charging and behaving very well as we would expect. So one thing I did was to add a digital power monitor to the system, and the sole goal for adding that during the charge cycle is to keep an eye on the accumulated power that the battery was able to take in during the charge phase, and that is going to be able to help us to verify the battery capacity to make sure that the capacity of this battery matches the manufacturer rating. Alright, so right around the 4-hour mark, the battery got to a full charge and the battery BMS was able to disconnect it from our DIY charger. So overall, the accumulated energy that we saw on our digital power monitor was right around 1.36 kilowatt hours. So one thing I've observed using these digital power monitors is that the current calibration, it seems to be about 5% off. So I have to always apply an error correction factor of about 5% whenever I'm using it to measure power or accumulated energy in this case. So accounting for the 5% error correction factor now gave us a total accumulated energy saved in the battery of 1.428 kilowatt hours. All right. Given that we have seen that the battery was able to accumulate 1.428 kilowatt hours during the charging phase, and also we made an initial assumption that this battery was shipped at 30% SOC, that puts us at about 0.633 kilowatt hours that the battery came with. So now what that tells us is that when we do the math, so we add the 30% SOC to the accumulated charge that we put on the battery during the charge phase, so 633 watt hours plus 1428 watt hours, that gives us around 2061 watt hours. And this means that by approximation, we are right at the manufacturer rating for this battery, which is right at the 2.1 kilowatt hour capacity rating for this battery. Alright guys, looking at all the observations and the tests and the estimates that we've just talked about, my honest and unbiased opinion about this battery is that this battery has passed our DIY charge test in flying colors. And when we get to the discharge phase, the hope will be that we will be able to replicate that by drawing the same amount of energy from this battery. And at that point, we see how the battery system is going to perform. Alright guys, as you guys know, the primary function of any battery system is really to store electrical energy. It doesn't matter how many volts it is or what system it's built for. The primary function of any battery system is really to be able to accumulate electrical charge and store them so you can use them later. And to be really honest, of all these battery technologies, the one that I'm really most excited about is the lithium phosphate battery chemistry or battery technology, because of how fast you can charge them and how fast you can discharge them, how efficient they are with no memory effects and all of that. And that's why I get really excited about lithium phosphate battery systems. And also another thing that makes me happy is to think about all the applications of these battery systems in the world of energy that we have today. So because of the efficiency of these lithium phosphate battery systems in storing electrical energy when you have an excess of the energy that you want to store, and also being able to deliver that energy to your load or your application when the original source of energy is no longer there, now you want to be able to use the energy that you have saved in your battery system. So the energy storage concept by itself had made it possible for these batteries to find use in multiple applications, going from renewable energy storage, be it solar or wind or other kinds of renewable energy, to portable power devices. Now, having that in mind, also if you have a good power inverter, so having a battery system like this kind of provides the power that you can use to drive your noiseless inverter. So if you think about it, back in the day, especially for those of us who grew up in third world countries, so for you to actually have any form of energy that is like your own private energy, you have to go get some gas and turn on some generator, and they are noisy. So having an energy storage like this solves our problem, because now if you have a few solar panels, you can just hook it up to your battery, charge up the battery. In the night, you hook it up to your inverter, so you have a steady supply of power that you can use to watch TV, drive some fans, recharge your phones, and all of that. So when I see a battery system like this, the things that go through my mind is not just, okay, is it going to be used in a boat? Is it going to be used in a car? Is it going to be used to start an engine? So when I see a battery unit like this, or a battery design like this, the only thing that I actually see is an energy storage device. And that is what I want you guys to take away from this video, is begin to think about a system like this. If you can afford it, what can you do to take good advantage of this awesome technology? This battery system actually comes with a very well written product manual that is brief and straight to the point. Alright guys, so let's take a closer look at the specifications and parameters of this battery. As we have already talked about, this is a lithium phosphate battery chemistry, and all the cell types inside the battery is going to be lithium phosphate. So the battery has a nominal voltage of 38.4 volts. It has a rated capacity of 55 ampere hours. It can store up to 2.1 kilowatt hours of energy. It promises an internal resistance that's going to be less than 40 milliohms, which is great, which means that this battery system can possibly support high surge currents at the times when you need them. In terms of the battery cycles, you can actually get greater than 4,000 cycles out of this battery system, and that means you can fully charge and discharge the battery 4,000 times. So if you kind of do the math, and you can see how many years that this battery system is promising. The battery comes with a BMS, which is a battery management system that can support up to 55 amps. And for the charge method, the battery supports constant current and constant voltage charge modes, which is essentially the charge modes or phases that is expected for lithium phosphate and lithium ion batteries. In the constant current charge mode, the current just stays constant while the voltage rises slowly. In the constant voltage mode, then the reverse is kind of the case there, and the battery supports all of that. It has a nominal charge voltage of 43.2 plus or minus 6 volts, and the recommended charge current of 11 amps, which translates to about 0.2 C. It has a maximum charge current of 55 amps, a maximum discharge current of 55 amps, a maximum 1 second discharge current of 200 amps, and a maximum continuous output power of 2.112 kilowatts. So this battery is also built with a low temperature charge protection. So this essentially means, as you guys can see here, means that if the temperature of the battery drops below 0 degrees Celsius during the charging phase, the BMS will kind of disconnect from the charger and stop the charging current from going into the battery, because at that temperature it's not suitable for charging the lithium phosphate batteries. So you can also use this battery system for your solar projects or solar applications. And I am seeing a recommended power here of greater than or equal to 700 watts. I don't know why. If you have a 200 watt solar panel array, I would think that should be fine as well. It's just that you're not going to get a lot of charging current to charge the battery system faster. So down here, the recommended charging current from your MPPT charge controller or whatever solar controller you're using, they're saying 11 amps, which is about 0.2 C, as we talked about earlier, or you can go to 0.5 C, which translates to about 27.5 amps. And if you use 11 amps, you will get the battery fully charged in 5 hours. If you go to 27.5 amps, which is 0.5 C, you can get the battery fully charged in about 2 hours, which is actually amazing. Now looking at what happens during the discharge phase, the battery has an undervoltage warning of 34.8 volts, and undervoltage recover of 36 volts, low voltage disconnect of 32.4 volts, low voltage reconnect of 37.2 volts. So the low voltage disconnect here is kind of the most important one, which is actually the trip point of the battery. As you know, you're discharging the battery with load applied. Once you get to about 32.4 volts, you should expect that the BMS of the battery should trip at that point, and that helps to protect the lithium phosphate battery cells inside the battery. So a couple more things I'd like to show you guys before we wrap up the spec review is that actually the BMS in this battery can do what is called SOC, which is the state of charge, which is how much energy the battery has accumulated, and that kind of correlates to the voltage level. It's not exactly a linear function, but at least you can kind of have an idea of the charge state by just measuring the voltage of the battery. And as you guys can see here, so this is a plot of voltage against SOC percentage as provided in the table to the right. So at 0 SOC, the battery voltage should be about 30 to 36 volts, and at 25% SOC, the battery voltage should be about 39 to 39.45 volts. And if you take it all the way to 100% SOC, which is when the battery is fully charged, the voltage you should be measuring should be greater than or equal to 39.99 volts. Alright guys, lastly, according to the user manual for this product, you can parallel up to 4 of these batteries, but series connection is not recommended. The goal of the discharge test is to fully discharge the battery, and in the end, we're going to look at the amount of energy that we delivered to our load, and we're going to use that to verify or validate the manufacturer battery capacity rating in watt hours. Our discharge goal is to apply about 1000 watts of steady state load on the battery system, and this will allow us to kind of see how long the battery can supply full power to that load. In the end, we're going to see how much power the battery is going to be able to deliver that load and for how long. To get close to our discharge goal of about 1000 watts, so we had the output of the DC to DC boost converter set to about 69.8 volts, and it was delivering a load current of about 14.14 amps, but a realistic power draw from the battery system accounting for all the power losses, boost converter efficiency, is really going to come from the back end, which is the actual battery voltage multiplied by the supplied battery current. So when you do the math, you see that we are actually discharging the battery at the rate of about 1075 watts, which is quite impressive. So what I did was to actually capture the performance of the discharge system, the performance of the battery every 20 minutes. So let's take a few seconds to kind of glance over the performance of the battery system as I was capturing it. Also, I highly encourage you guys to pay close attention to all the measuring devices that I have on the setup, the DMMs and the power monitors, the current probes, to kind of see how the measurements and everything is aligning up. And in the end as well, I'm going to be able to take all the data that I collected and I'll put all of that in a nice graph that will show you guys the discharge response of this battery system. Alright guys, overall I am very happy with the discharge performance of this battery. It was able to provide 1000 watts of steady state power to our discharge load, as you guys have seen, and that's amazing. And lastly, looking at our digital power monitor, we saw that this battery system was actually able to deliver a total of 2.107 kilowatt hours of energy to our test load, and it was able to do this while delivering a steady state power of 1000 watts to the same test load for 2 hours. If you ask me, I would say this is quite impressive. And this has again given us a validation point that this battery system essentially lives up to every single spec that the manufacturer has rated it for. For the solar charge test, what we did was to use the same exact charging setup that we used during the initial charging. The only thing that we modified was that we replaced the 24 volt server power supplies with our actual 30 volt solar array. And the reason we're using our DIY solar battery charging system is because, as you guys have seen in most of our videos, we try to encourage you guys to do DIY projects as a more affordable option for those of us who cannot afford MPPT charge controllers. So essentially, all we had to do was to connect the battery to the DC to DC boost converter. We adjusted the output voltage of the DC to DC boost converter to match the manufacturer recommended charging voltage, which is about 43.8 volts, and after we did that, we closed the circuit breaker and slowly increased the charging current. So overall, what we saw was that with the battery connected, the solar panel system was delivering about 30 amps to the charging system, and overall the battery was receiving a charging current of about 17.38 amps during the constant current mode or constant current phase of the battery charging. And overall, considering the charging voltage of the battery at the time and the charging current, so we saw a continuous delivered power going to the battery of about 640 watts, and this is during the constant current mode. Alright guys, at this point all we really had to do was to leave the battery to charge, but we kept an eye on it to make sure everything was running well. We kept a fan on the system cooling it, as you guys can see here, and right about 4 hours later the battery got to 100% SOC, meaning that it's fully charged. And at this point the BMS actually disconnected the battery system from the charging system, which is a great safety feature that the BMS performs to prevent the battery from overcharging. And finally, looking at the overall accumulated energy in watt hours, accounting for a 5% correction factor. So we saw that this battery was actually able to store about 2.236 kilowatt hours of pure solar energy coming from the solar panels, and this is amazing. And again, this actually validates the storage capacity rating of this battery of 2.112 kilowatt hours. We actually exceeded it here, which is amazing. Alright guys, overall all I can really say is that this test has given us another way to validate the specifications of this battery, and as you guys have seen, the battery solar energy storage performance was great, and we have also validated that. Alright guys, that's really it for this video. Our goal for this video was to conduct a spec review on the battery system, and right after that we actually tested the battery to make sure that the battery system lives up to the specs that the manufacturer has rated it for. And as you guys have seen in the video, we initially charged the battery, then we discharged it with a steady state load of 1000 watts. And right after that, we were able to recharge the battery system using our DIY solar charging system. Overall, my unbiased opinion about this battery, based on all the observations and tests that we have conducted, is that this battery system has performed very well. We have charged it and discharged it, and we get the same amount of energy storage and the same exact amount of discharge energy from the product. Alright guys, depending on your budget, if this battery system is something you can afford, I'll highly recommend it to you guys for your future DIY projects. Alright my friends, I will see you guys in the next video.